We're used to seeing the universe in all its glory. Stars, planets, nebulas, supernovas, black holes. What if I told you that 85% of the universe is made of something invisible? Something we cannot see, touch, or detect in any way. Yet it's there, and we know it. This invisible substance makes up more than 8 times the mass of all the normal matter in the cosmos. And it's all around us, shaping the universe and affecting everything in it, including us. So what is it? Okay, there are many ideas, but none have been proven. What we do know is that this mysterious stuff has a powerful gravitational pull, an invisible force that affects things we can see. We call this dark matter, okay? And one of the greatest cosmic mysteries is why we can't see it. Welcome to my channel. Today, we'll explore what dark matter is, why we know it exists, and some of the most intriguing theories about what it might be. Join me on this journey as we delve into the unknown and discover what might be lurking in the shadows of our universe. Have you ever heard of dark matter? It's a mysterious substance that scientists believe makes up a whopping 80% of the matter in the universe. That's right, 80%. And yet, we can't see it. So, what is this mysterious substance, and why should you care? Well, dark matter is basically like a ghost, okay? We can't see it, but we can see the effects it has on other things. For example, when light passes by a massive object, it can bend, warp, and distort. And because we know that dark matter has gravity, we can see how it's affecting the light around it. We call this gravitational lensing, and it's basically like using a magnifying glass to look at things that are very far away. But wait, there's more. Gravitational lensing also tells us how much mass an object has. By looking at how much the light is bent, we can work out how much mass there is in the object. And here's where dark matter gets really interesting. Scientists have seen lots of objects in space that have way more mass than they should have. They're like mini black holes, but without the big gravity. We think these objects are made of dark matter, but we don't know for sure because we can't actually see them. But hold on, it gets even weirder. Scientists also know that dark matter makes up a lot of the stuff in between galaxies. They've seen it create huge ripples and waves in space, and it seems to be everywhere, but they still don't know what it is. So why should you care? Well, if we can figure out what dark matter is, it would be one of the biggest scientific breakthroughs of all time. It would change our understanding of the universe and our place in it forever. Plus, it's just plain cool to know that there's so much stuff in the universe that we can't see. And now that you know what dark matter is, it's time to learn why it's such a mystery. You see, dark matter doesn't play nicely with the other matter in the universe. It's like the kid who sits alone at lunch. No one wants to talk to him because he's just too weird. And that's because dark matter doesn't interact with normal matter in the usual ways. It doesn't emit, absorb, or reflect light. It's totally invisible. Not only that, but dark matter is also kind of shy. It's like the kid who sits in the back of the class and never raises their hand. It doesn't interact with normal matter very much at all. Because of this, scientists can't see dark matter directly. They can only observe its effects on other things in the universe. One of the ways scientists have learned about dark matter is by studying how galaxies spin. You see, galaxies are like giant spinning tops. They spin and spin and spin, and they take all the dark matter with them. Okay, but here's the thing. Galaxies shouldn't spin as fast as they do. According to the laws of physics, they should slow down pretty quickly, but they don't. Spin and spin and spin for billions of years. And we think that's because there's all this invisible dark matter holding them together. Another way scientists have learned about dark matter is by studying gravitational lensing. You see, when light passes by a massive object, it can bend, warp, and distort. And because we know that dark matter has gravity, we can see how it's affecting the light around it. And by studying how the light is affected, we can learn more about the dark matter itself. Although we can't see dark matter, scientists are pretty sure it's there because it wouldn't make sense if it wasn't. I mean, think about all the galaxies out there. They're spinning, and they're all held together by this invisible stuff. If there wasn't dark matter, then the universe would be a pretty boring place. So what are some possible solutions? Well, the leading candidate for dark matter is called WIMPs, or weakly interacting massive particles. As the name suggests, these particles are massive and don't interact with normal matter very much. Another popular theory is that dark matter is made up of ixions, which are hypothetical ultralight particles that were proposed in the late 1970s. Ixions are thought to be one of the best candidates for dark matter because they interact with normal matter in a way that's consistent with observations. Some researchers even believe that primordial black holes, which are small black holes that formed in the early universe, could make up dark matter. There are also other ideas, but those are the most popular ones. And no, dark matter is not the same thing as dark energy. Dark energy is a separate phenomenon that is thought to be responsible for the accelerated expansion of the universe. Now that you know what dark matter is and why it's such a mystery, it's time to learn how scientists are trying to solve this cosmic puzzle. First off, let's talk about direct detection experiments. These experiments are designed to detect the faint signals produced when dark matter particles collide with ordinary matter. One of the most sensitive experiments of this type is xenon, which uses a massive tank of liquid xenon deep underground in an Italian mine. By looking for tiny flashes of light and ionization in the xenon, scientists hope to catch a glimpse of dark matter particles. Then there's indirect detection experiments. These experiments look for signs of dark matter in space. For example, scientists are looking for the telltale gamma rays produced when dark matter particles annihilate each other. The most promising results come from the Fermi Gamma Ray Space Telescope, which has spotted a mysterious source of gamma rays coming from the center of the Milky Way. Some scientists believe this could be a sign of dark matter, but others are more skeptical. Finally, there are collider experiments. These experiments smash together protons, or electrons, at nearly the speed of light and look for new particles in the debris. The most famous collider experiment is the Large Hadron Collider, which is located near Geneva. So far, the LHC hasn't turned up any evidence of dark matter, but the search is still ongoing. Scientists are also looking for other signs of dark matter, like unusual gravitational effects or variations in the cosmic microwave background, and who knows what else they might find. The bottom line is that scientists are pursuing every possible lead in the search for dark matter. So when will we find out if dark matter exists? Well, no one knows for sure, but many experts are hopeful that we'll have a definitive answer within the next decade or so. If we do find dark matter, it would be one of the biggest scientific discoveries in history. It would change our understanding of the universe and our place in it forever. But even if we don't find dark matter, the search will still be worthwhile. That's because every time we explore the unknown, we learn something new about the universe. And who knows what other mysteries we might solve along the way. The hunt for dark matter is one of the most exciting quests in modern science. With so many brilliant minds working on a problem from so many different angles, it's hard not to be optimistic. Who knows? So maybe you'll be the one to crack the case and win the Nobel Prize. But even if you're not a scientist, you can still play a part in the investigation. By staying curious and asking questions, you keep the mystery alive and inspire the next generation of explorers. So keep looking up at the stars and wondering about the invisible stuff that makes up our universe. You never know what you might discover. With that said, if we unlock the secrets of dark matter, could we finally understand the true nature of reality itself? Are we just a small part of a much larger and more complex picture? Then what other cosmic mysteries lie beyond the reach of our current understanding? The possibilities are truly mind-boggling. Perhaps dark energy, the force that's driving the accelerated expansion of the universe, we also have its secrets revealed. Maybe there are other dimensions of reality that we're not aware of, or alternate universes that exist alongside our own. The more we learn about the fundamental nature of the cosmos, the more we realize just how much we don't know. So keep your eyes open and your mind free to wonder. Who knows what wonders and mysteries the universe has in store for us? Thank you for joining me on this journey today. And remember, the universe is full of wonders and mysteries beyond our current understanding. Keep exploring and stay curious. You never know what you might discover.